Students, in this video I will go through assignment U2A04, which is directly out of the Envision textbook from page 134 to 135. In this assignment we will go through analyzing different kinds of rigid motions. Okay, so for question number 1 here it says, how can rigid motions be classified? How can rigid motions be classified? I actually made a neat little graphic for you guys to demonstrate that idea, and which can also be found in the lesson. So these are the 4 different types of rigid motions. Well, actually 3 unique rigid motions, and one of which is just a combination of the other 2. So first of which is a translation, then a reflection, a glide reflection, which is a combination of translation and reflection, and lastly is the rotation. So all of these, okay, what makes these rigid motions is the fact that they all preserve length and angle measures. Okay, everything about the image is exactly the same as the original object. The only thing that is different about, or the only rigid motion that is different from the other 4 here, okay, is the reflection. Whenever you're performing a reflection, the orientation changes. So, which is what I'm referring to right now is the middle column here. So, is orientation preserved? So if you look at a translation, okay, the translation just moves an object horizontally or vertically. The orientation of it is preserved. So notice that triangle ABC is going counterclockwise. The image A prime, B prime, C prime is also counterclockwise. If you look at a reflection, on the other hand, though, right, on the left is ABC, on the right is also ABC, but it's going in the other direction. It's A prime, B prime, C prime. It's going clockwise. So the orientation is not preserved under a reflection. Since glide reflection is a combination of reflection and translation, then of course the orientation will not be preserved there. The rotation, even though the whole orientation of the object will be altered, like manipulated with, rather, not altered, the orientation, the way in which we read the object, so here I'm going ABC, this is clockwise right now. Notice, after the rotation, it is still clockwise. The orientation is still preserved under a rotation. Anyway, so this graphic here culminates everything about the solution to question number 1. I'm going to go back over here. Vocabulary. Is it correct to say that the composition of a translation followed by a reflection is a glide reflection? Explain. It is correct to say this because of the fact that so I'm going to say yes. And the reason is a glide reflection is a combination of translation and rotation, or rotation and translation. It is just the very definition of what a glide reflection is. Alright, question 3. Tamika draws the following diagram as an example of glide reflection. What error did she make? So I'm guessing this is the diagram. My apologies on not ordering the diagram right next to the description there. But it says, what error did she make here? So we go from ABC, so it looks like there was a reflection that happened, and then from the reflection, something happened. It looks like there's going to be a translation, right? It says here that what example of glide reflection. So glide reflection is reflection and translation, or translation and reflection. So notice here, this is C prime, B prime, and A prime. Really, what should have happened is, okay, A double prime should not be here. C double prime should not be there, and nor should B double prime. So there was definitely an error. There was an error in the translation. Okay? All right, moving on. Question number 4 to 7 here says use the figures for exercise 4 to 7. Identify each rigid motion as a translation, a reflection, a rotation, or a glide reflection. So question number 4 says triangle WYX becoming triangle NLM. So WYX becoming NLM. Where is NLM? NLM. Oh, here we go. NLM becoming NLM. And what we need to do is identify the rigid motion that took place here. So it looks like, and the way in which we read this, okay, W corresponds with N, Y corresponds with L, and X corresponds with M. So if we look at this, what really happened here? It looks like, was there a translation? No. There was, in fact, a reflection that took place because the orientation has been reversed. So this is going to be a reflection over the line y equal to 1. Let's take a look at question number 5. So question number 5 says DFE going to WYX. DFE going to WYX. DFE going to WYX. So this looks like a translation. A translation of what? So going from D to W, going from D to W is going to be a translation of, we're going to move to the left by how much? So this is 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be moving 10 to the left and 1 down. Let's take a look at question number 6. WYX to ABC. WYX to ABC. WYX to ABC. Looks like it's going to be a translation, and then after the translation, it's going to be a reflection. So we're going to be translating how much? Looks like it's going to be a translation of, so A, we're going to be translating horizontally 3 plus, what is that? So we're going to be translating horizontally 10 units to the right, and we're not going to be translating in the vertical direction, and then afterwards we are going to be reflecting over line y equal to 1. So it's going to be a glide reflection. And then we're going to go NLM to QRP. NLM to QRP. NLM to QRP. NLM, which is this guy right here, to QRP. So what is this? NLM to QRP. Well, there's actually one. There are again. There's an infinite different ways for us to do this. So the way in which I see it, okay, is if I connect these things, because NLM and QRP, if you notice, QRP is clockwise, NLM is counterclockwise. So that means there has to be a rotation involved here. I mean, not a rotation, a reflection involved. And if you look at this, M corresponds with P, L corresponds with R. You see what I'm getting at? And N corresponds with Q. This is actually a point reflection. Or you can think of this as a rotation. This is a rotation, whoops, this is a rotation of 180 degrees over the point -3, -2. And of course this is not the only way to think about it. You can also, think of this as a combination of like maybe two different reflections, right? So another way that you can do this is perhaps we can reflect. And then after we reflect again. Okay? So we can reflect over, so this is another way of doing it. So we can reflect first over the line x equals to -3, and then reflect over the line y equals to -2. So this is an alternative, both of which will give you the same thing. Okay? So two different ways of doing it. Alright. Let's take a look at the next one here. It says error analysis. Damien draws the diagram for the glide reflection, reflecting over y-axis, then translating 7 units to the right. What error did he make? So, the reflection didn't take place. So, the orientation here. So, reflection did not take place. So the reflection did not happen correctly. The orientation is hasn't been reversed. Okay, moving on to question 11. What are the coordinates of the vertices of triangle A prime, B prime, C prime after a reflection across a line through point P with a y-intercept at y equal to -2, followed by a translation of 3, 3? After a reflection across a line through point P with a y-intercept of y equals to -2. So point P here, after a reflection across a line through point P with a y-intercept of -2. So point P has coordinates of 10, 8. And it has a y-intercept, which I'm going to call lowercase b here, with 0, -2. So, excuse me. So the slope of this line will be 8 minus -2, which is 10, over 10 minus 0, which is going to be 1. So that means this is going to be the line that I am going to be reflecting over, and actually I'm going to make a dotted line instead because I can't draw straight. This app does not have a straight line functionality, right? Okay, so anyway, so I have this. And what we're going to be doing is we're going to be reflecting this and then translating it. So when we reflect this, so point C reflected over this line, where will it end up? It will end up over here. This is C prime. Where will B prime end up? B prime will end up over here. And where will A prime end up? Let's see here. 1, 2, 3. 1, 2, 3. It will end up over here. So this is my triangle. Alright. And then I'm going to be translating this 3 to the right and 3 up. So A prime, a double prime rather, will end up at, so I'm at 9, 0 right now. If I add 3 to it, it will be 12, 3. B double prime, where will it end up? 9, 4. So 9, 4 plus 3, 3 will be 12, 7. C double prime, where will it end up? So C right now is located at 7, 2. If I add 3 to it, it will be 10, 5. So these are the points of A double prime, B double prime, C double prime. Let's take a look at question number 18, 19, and 20. It says, for exercise 18 to 21, write a rule for each glide reflection that maps DEF to D prime, E prime, F prime. Okay, so going from D to D prime. Boy, it would help if they gave us a grid for this, wouldn't it? So let's see here. Going from D, E, F. So I will go over here and do the following then. I'm going to take a moment, I'm going to take a snapshot of this, and I'm going to go to a graph paper, and I'm going to be over here. Nope, I'm not going to use this. I'm going to use this. Okay, so I'm going to import that. And I am going to use grid paper. Okay, here we go. So I want to come up with the rule that describes this thing. So I'm just going to get this over here. And I want to plot out DEF. So let's take a look. So DEF, I'm going to make myself a grid. Okay. So DEF, where is DEF? So 7 comma negative 2. So 2, 4, 6, 7 comma negative 2 is right there. So that's D. E is 3 comma 9. 3, 2, 4, 6, 8, 9 is right there. I want to get rid of this box. Okay, so that's D. E is over here, and F is 8 comma 6. So 8 comma 6, where will that be? So that would be one more over, and then 6. So it's 2, 4, 6. Boy, they didn't make it easy, did they? 2, 4, 6, 8. 2, 4, 6. This is F. Okay. So this is the shape that I will need to perform a glide reflection for. And D prime, E prime, F prime, negative 5 comma 1. Where's negative 5 comma 1? 2, 4, negative 5 comma 1 is right here. This is D prime. Whoops. And E prime is negative 1 comma 12. Negative 1 comma 12. So if this is 9, 10, 11, ooh, hold on, I need to get rid of this. This is going really off the grid. Okay, so 10, 11, 12 is right there. This is E prime. Oh boy. Okay, and lastly F prime is negative 6 comma 9. Negative 6 comma 9. So 2, 4, 2, 4, 6, 2, 4, 6, 8, 9, right there. So this is F prime. And this is the shape that I'm looking at. This is the image. Okay. So what is this that we are looking at? This looks like it's going to be a translation and then a reflection. So it's going to be translating how many units? It looks like it's going to be translating 4 units up and reflecting. So let me go back over here then. I want to write my answers over here because this is the thing that I will be uploading. So it looks like it's going to be a translation of 0, 4, And it's going to be a reflection over the line, over which line? Over line x equal to 1. Okay, so that's the first one there. Oh boy, alright. We're going to do number 19 now. Let's take a look at number 19. And I will erase this. We're going to take a look at 19. Here we go. Alright, so one more time, we're going to draw a nice grid. And here we go. Alright, so -5, 8. -5, 8. So I'm going 2, 4, 5, 2, 4, 6, 8. Oh, right there. Okay, so that's D. And then 1, 4 is right here. That's E. And then F is 6, 3. So 2, 4, 6, 3. That's F. Okay. -5, 8, 1, 4, and 6, 3. I just wanted to make sure that I got this. -5, 8. Yes, it is. Okay, so that's triangle DEF for you. Okay, so, and the image is going to be -3, 8. -3, 8 is over here. That's D prime. And then 3, 12 is going to be E. So 3, 12, 3, 12, 8, 9, 10, 11, 12 is going to be up there. So that's going to be E prime. Okay, let me just do that again. So 3, 12. So 3, 9, 10, 11, 12 is right there. That's E. There you go. Okay. And 8, 13. 8, 13, where are you? So let's see here. 2, 4, 6, 8, and then 13. Whoa, boy. Is going to be like right there. Okay, so here we go. So this looks like it's going to be a translation of 2 to the left, no, 2 to the right, and reflected over line y equal to 8. So translation of 2 to the right and reflecting over line y equal to 8. So, and then the last one here, 0, 4, 6, oh, I gotta go back to the other app. Okay. Yeah, I know it's a little annoying, but for the pursuit of knowledge, right? Okay, so we take this, and again, I want to draw a grid. Okay, I just wish that they make these numbers a little smaller. 0, 4 is over here. 6, 3, that's D, by the way, and then 6, 3, 2, 4, 6, 3 is E. And 9, 8. Geez, they have to choose these large numbers. 2, 4, 6, 8, 9. And 2, 4, 6, 8. I consider any number above 6 large. Well, at least when it comes to graphing. Just because I have to make my grid pretty big. Okay, So I have my DEF. Now I'm going to graph -6 comma -8. -6 comma -8. Oh boy. 2, 4, 6. 2, 4, 6, 8. So this is my D prime. Whoops. Ah. 2, 4, 6, 2, 4, 6, 8. Right there. Okay. And E is located at 0, -7. Okay, 2, 4, 6, 7. And my F prime is 3, -12. Okay, 3, -12. And then 2, 4, 6, 8, 10, 12. Right there, F prime. Okay, here we go. So now that I have this drawn, there's no other way of getting around this. Okay. It looks like it's going to be a translation and then a reflection. Again, of course, it's a glide reflection, right? So, you know what? Just to change it up a little bit, maybe I will do a reflection first. So let's see here. So from here down, how much is that? That is, I'm talking about 2, 4, 6, 8, 10. So we're going, so this is so right in the middle would be 5 below that. So that means 2, 4, right there. Whoops. So 2, 4, there you go. Okay, yes, that is it. So y equals to -2 is going to be the reflection. And then afterwards, we're going to translate this, because this is where E will end up. We're going to be translating this 2, 4, 6 to the left. Wait, one more time. 2, 4, 6. Yep. So reflecting over y equals to -2. And then translating 6 units to the left. And of course, this is not the only way. There are infinite number of possibilities for what it can be. And that's it. Okay.